Hello and welcome to this video where I want to talk about magnetic levitation display. So in this video I will demonstrate a magnetic levitation display by showing a video that I have recorded. I will describe the 6 different types of magnetic levitation and I will explain how the magnetic levitation display works. However, I will not explain how magnetism works. But there are a lot of resources online and a lot of really good videos on YouTube if you want to look more into that. So a magnetic levitation display typically uses electromagnetic levitation, EML, or permanent magnet levitation, PML. And these technologies allow objects to hover and rotate in mid-air, creating something that's very visually striking. So electromagnetic levitation, EML, involves electromagnets generating a magnetic field to counteract gravity. The system often includes sensors and feedback mechanisms to stabilize the levitating object. Permanent magnet levitation, PML, uses carefully arranged permanent magnets, such as Halbach arrays, to achieve stable levitation. These systems are often simpler and more energy efficient than EML systems. And these magnetic levitation displays are popular for showcasing products, art, or educational demonstrations, as they provide a 360-degree view and a very futuristic aesthetic. And you can also spin the parts so they can have them rotating while being suspended in air, so it's quite visually striking. Okay, next I'm going to play a video that I recorded previously of a magnetic levitation display. This video lasts 1 minute and 40 seconds. Okay, today I'm going to talk about magnetic levitation display. So here I have an object that's levitating. It has strength here. If I turn this off, it snaps in here. That's because there's a magnet in the top here. And this is a tool cut out just to show the internal, but it has a metal piece on top. So that's what is attracting the magnet. And so the magnet attaches to here, but when the display is turned on, you can adjust the strength here of the magnetic field, so you can adjust it for different weights of objects. So I'm going to turn this on. Now it's on. Now I just have to balance it when I put it in. And there we go. Now it's levitating. And I can demonstrate that by taking this cutting board and sliding it over. There's nothing holding it up. Just magnetism. And you can spin it. It's a little wobbly, so I need to stabilize it. But yeah, that's how a magnetic levitation display works. Okay, next I'm going to talk about the 6 different types of magnetic levitation. So number 1 is electromagnetic levitation, EML, and this involves electromagnets creating a magnetic field to support an object. Maglev trains often use this method, where the magnetic force lifts the train above the tracks to reduce friction. 2. Electromagnetic levitation, EDL. This uses induced currents in a conductor to create a repelling force. For example, superconducting magnets on a train induce currents in a guideway, generating lift and stability. 3. Permanent magnet levitation, PML. Permanent magnets are arranged in a specific way to produce stable levitation. Systems like Halbach arrays optimize the magnetic field for levitation and guidance. 4. Diamagnetic levitation. Diamagnetic materials, which create a weak opposing magnetic field, can levitate in strong magnetic fields. This is famously demonstrated by levitating small objects like frogs or graphite. 5. Earnshaw's principle-based levitation. This uses feedback control to stabilize an otherwise unstable system, such as levitating objects with varying magnetic fields. And 6. Induct track systems, a form of passive electrodynamic levitation, which employs Halbach arrays of permanent magnets and requires motion to generate levitation forces. Okay, so let's talk about this magnetic levitation display. So it's a combination of a permanent magnet and a temporary magnet, where the temporary magnet is an electromagnet. And when the power to the magnetic levitation display is turned off, only the permanent magnet is active. And you could see that in the video where when I turned off the magnetic levitation display, only the permanent magnet was left active, and it's basically kind of sucked the tool display into itself because the electromagnet was no longer there pushing the part down away from the permanent magnet. When the power is turned on, both the permanent magnet and the electromagnet are active. And you can see the adjusting dial on the side of the magnetic levitation display. That is adjusting the strength of the electromagnet. The permanent magnet is the same no matter what, but the electromagnet is what is being adjusted when you turn the dial to adjust to the weight of the display item. When the object to be levitated is placed at the right distance away from the magnets, there's a force balance between the pull from the permanent magnet and the push from the electromagnet. And this is what makes the object float in the air, levitate. That concludes what I wanted to talk about in this video on the magnetic levitation display. I hope you found it interesting. Thank you.